where did we leave off on this problem? We left off, I gave you this, let me put a pen going here. I left off with this ordered pair. Well, 1, comma, I can't tell the comma, negative square root of 3. And there should be an I in there because, yeah, that's, if you were to graph that ordered pair, 1 down the square root of 3, which is not even a 2, it's like 1.7, it's down here. Just that dot right there, which if you go scroll up, it looks very similar. Let's see, where did I graph something earlier? Yeah, look at this. I graphed one over here, you see, when we were doing it as a, where is that angle going to be? The vector I didn't graph because I didn't really know what it was in this form. But now that I know what it is, you have to remember that the y-axis is really your BI. Your complex part. So if I graph a vector there like that, that's exactly where it would have been as a complex number. It's where it is even when you look at where that point is, the rectangular. But what we'll do is to make everybody happy, we will, where did I lose my black? I'll go 1, comma, I'll put the I in front square root of 3. That would be rectangular because it's definitely not trigonometric because you don't see any trig functions. This up here was trigonometric, but it meant the same as this, okay? But I put, if you graph it now as a complex number, we have that vector coming out. All right, do we have some notes to fill in here? We always got notes to fill in, right? What are the steps from converting rectangular to trigonometric form? Okay, that means this. That means if I have a vector, why does my pen keep disappearing on me? If I have a vector like 2, comma, 3i, and we know what it's going to look like, we know it's going to look like 2 on the real, up 3 on the y, but since it really means bi, the dot looks like it's up here, but it's 3 dimensions if you remember. So we will connect it from the origin, and it's basically coming out at you. It's coming out at you if you're standing in that rectangular piece here. Picture it coming out at you. There's your complex number going all the way to that point. So I want to convert this rectangular into trigonometric, which basically means cis. R cis theta. Or if you're a glutton, R cosine of theta, comma, I sine of theta. So that's either way, either abbreviated or long. So first thing, sketch the graph of the number x plus yi in the complex plane. I just did one. See that? I did sketch that. Now let's find r. Like if we're going to turn this into trig, you sort of need to know how long this is. That's called r. And we have a formula from the other page, if you remember. R was equal to the square root of x squared plus y squared. So that's how you would find your R. Then we also need to know, because we need R, because R is what's going to go here in front, or go all the way around here, right? I don't know why I wrote, yeah, if I write the R, that was where I wrote earlier. Actually, I was talking about this R right here. Then we need the angle, because you got an angle here, see? You got an angle. It's the same angle twice. So that's when we use the tangent of theta will equal to y over x. So that's the steps. Find R with the equation R equals square root of, you have a hard time doing straight lines, x squared plus y squared. Then we find the theta by using the equation tangent of theta equals to y over x. There's your steps. I would ask if you had any questions, but you're not in here. Okay. So let's move on to the next page. We might come back to the, I might come back to this page just to finish my problem there that I made up. Converting from rectangular to trigonometric. Okay, so I'm already in rectangular here. And we don't have an angle. But if you just thought of the triangle that you're creating, okay, if I draw it out, and the real part is the square root of 3, negative square root of 3. So that's going to be on the x-axis. See, I knew I couldn't go straight. Here's -1, here's -2. Square root of 3 is between 1 and 2, so it's somewhere about here. Okay, I'll put a little tick mark there to remind me. Here's 1, here's 2. It's about in here. Now the y-axis is your BI. So BI, that looks like, and we're using radians too, by the way. It says that. Thanks for telling me. 1i. And so it's positive, so you would picture going up, like y is 1. So the point, negative square root of 3, comma 1 is up there. So you're just going to have to picture 3D. There's this vector coming out. It's up there. Okay. So it's, you can't even, I should have gone higher up, but I can't tell. It go up. I thought I was up, but it didn't mark up. So it looks at least now I can visualize this triangle here. That's a right triangle. And so if you think about how far did I go in the x direction, well, that value was a -2. And how high did I go? That value is a 1. Oh, looking at this, I knew I was going to not draw it straight. There need to be classes how to draw straight when you're not looking at your fingers. So there's that triangle. There's the negative square root of 3. There is the 1. Why did I write here? I don't remember what I wrote right here. I don't even think I wrote the, okay, whatever I wrote. So you went left square root of 3 and you went up 1. So R should be, let's see if we can get this worked out. Square root x squared. So I'll show all the work. And then you're going to say, oh, I don't need all that work. Negative square root of 3 squared plus 1 squared. That's my x. That's my y. So that turns into something much simpler like +3, because square root times square root loses the square root. 3 times 3. You say square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. Either way, however you think it, plus 1. That's the square root of 4. That's equal to, r is equal to 2. Now I still need the angle. Tangent of theta is y over x. The y was the bi, so that was a 1. We used the 1. That's the what I wrote right here, over the x was a square root of 3. I'm sorry, it was a negative square root of 3. The question is, do negatives matter? Yeah, they matter because it tells you what quadrant you're in, right? So I'm going to rationalize that and make it a negative square root of 3 over 3 just to be nice. So that's tangent of theta equals to this. So I'll erase all this when I do the second problem. So I need to do, this takes me to, let me change color again, arctangent of the negative square root of 3 over 3. Now, personally, I liked it better as this. And why do I like it better? Because then if I draw that triangle, can't even connect those dots. Tangent is opposite. This is my theta right here that I care about. I'm just calling that theta. Opposite over adjacent. So I would call this the 1 and call this the square root of 3. So I know that looks to me like a 1, 2, square root of 3 triangle. So across the street from the 1, theta must be a what kind of angle? Theta is some sort of a 30-degree angle, which is pi over 6. However, I'm not in quadrant 1. I'm in quadrant 2. So think of the picture more like, since we can't really, let me erase something here. I never practiced my eraser. Where is the eraser? That's an eraser. So let me make a better picture of what I have that matches up. Okay, good enough. Pen. And go to blue. So if I have my grid and I am up here at a 30-degree angle, right here, it's 30 degrees. Put that, let's see it. Theta, right here. That didn't help. So if that would be 30 degrees, 60 degrees, 90 degrees. This is a total of 3 pi over, I'm sorry, it's 3 pi over 6s, right? 3, and the reason he wants radians, 3 pi over 6s, which means pi over 2, which that's what I know that to be. So that's 1 30 degrees, 2 30 degrees, 3 30 degrees, 4 30 degrees, 5 30 degrees, right? Oh, that's bad. I think I draw better on my iPad, a little bit better, not much though. Doesn't line up. So that's 5 30 degrees before I get there, or do it easier. Take 180 degrees and just take away the 30 that I used up for this angle right here. So that's a 150-degree angle, which means 5 pi over 6s. So it's not pi over 6 because that negative tells me I was in a different quadrant. And so I was going to put a negative, and I'm going to put 5 pi over 6 is my angle. So now I have my R. Let me erase everything and just put down what I think I have. Where's my eraser? I'm not going to erase my R. I'll leave that answer there. Let me erase all of this work. And technically, because I just need a little more room here. Okay, so if R was 2, and theta is 5 pi over 6, then my equation is going to be, my coordinate would be r cis theta. So you can call that 2 cis of 5 pi over 6. That's your trigonometric form. And that's what he wanted, converting rectangular to a trigonometric form. But I did it in a polar form. But there's nothing wrong with that answer. You want the full answer? Long 2 times, I like the cis better, 2 times, it was the cosine of 5 pi over 6, comma, I times the sine of 5 pi over 6. Both answers are good. I like my iPad better because I can zoom in and I can make more room. Okay. Oh, I didn't do the second problem. Bummer. Let me do this. Let me, I can go and add extra room at the bottom of this by hitting right here. I can, this thing's in the way, tab the way. I'm gonna hit there. I just added a couple extra rooms here. So B was, I'll rewrite it. B was, wants me to convert a -3. Is that what it was? A -3. I don't know, find it in my paperwork. Let me go all the way up. What am I looking at? Way up, way up, way up. Oh, it's a -3i. All right, so I'm going to do B. I'm going to convert -3i into, I guess we're still doing trigonometric form. Trig form, okay? So how do I write this as a complex number? Simple. It's a 0. There's no real part. 3i. If I graph it, it's going to mean I'm on the y-axis because x is 0. I'm basically just going up 1, 2, 3. And that's 3i because I'll change the color so I can show you where it is. It's starting at 0, 0, going straight up, stopping here. There's my arrow there. That's what it looks like. It's just on that y-axis. So let's find r. Let's find r. I did make more room here, so I should be able to have enough room, I'm hoping. R should be, now I'm only using the 3 and I'm using the 0. Okay, so r is the square root of 0 squared, which is 0, plus 3 squared, which is 9. Square root of 9 is 3. Well, that's not very exciting. Well, you're going to see something in a minute why it's just a 3. Well, you could have counted it yourself. 1, 2, 3. Theta is, no, we don't do it that way. We say tangent of theta is the y, 3, y over x. Uh-oh. That's bad news. Did I make a mistake or is that legal? Anybody? It's undefined. I can't find theta from here. It's undefined. Undefined. It looks like I made a mistake, but I didn't. Where is tangent undefined? Well, if you graph any xy plane on that unit circle, let me try to do a nice unit circle. Which of these points is tangent undefined? Well, I hope you say it's the point where the y value is 0. I'm sorry, the x value is 0. Because this is y over x. So where is the x 0? It's 0. X is 0 here, and x is 0 here. And which one do I want? You know what? I drafted the wrong way, didn't I? It's 3. That is so silly. Should have been down 3. 1, 2, 3. I bet some of you saw that, but you're just too nice to call me. The vector went down here. So that clarifies which of these answers do I need. I need this one right here, because that's the one that I have a negative. Yeah, I wrote it as positive here too. 3. If I don't know, maybe I copied it wrong the first time. I don't know. If there's I think there's a negative there. So I'm going to take theta to be 270 degrees. And does he want radians or degrees? Let's go back all the way up. He wants that one in degrees. Okay, you're confusing me, Mr. Pearson. So we're going to use theta will be 270 degrees. And we already found r. R was going to be a 3, because that's the it came out to 3 because of this. You can't take this. The square root of a number is never going to be a negative 3, even though it is down. But that just tells us our direction. If we go all the way around, that's why we're down here. So, okay. So how do I write my answer? My answer I could say it's r cis of theta, which is where I usually like to say r was a 3, and then I can say cis of my 270 degrees, or you could write 3 and be really fancy, cosine of 270 degrees, comma, I sine of 200 and I can't go no further. That's the disadvantage of doing it here. 270 degrees. Okay, moving back up. There was more problems on this page. Write each complex number in its alternative form using calculator approximations. Well, guys, good luck. I don't have my iPad, so I don't have my calculator. So you are going to be pretty much on your own to do the calculations, because you're going to have to type it in with your calculator. Okay. So you're just going to be typing in the cosine of 125 degrees and the sine of 125 degrees. Is 125 a special angle? I think it is. 125. I'm just going to say could I do any work to help you out? Let's see what, this is 45. This is 90. Oh, I'm thinking of 135. Oh, no, can't help you. It's not a special angle. Just type it in your calculator and give it a couple decimal places, and I should be seeing you give me a number. That's this one right here, 6 times this. And then you're going to go plus another number, and you're going to put an I here. That would be what the calculator is going to give you. Just key it in yourself. And same thing with B. I can't do a whole lot without it being on my iPad. I'm not running my calculator. You know, if I'd have thought about it, I could have plugged both in. Next time. I don't know if I want to do it with this program much. I just needed to see that I could learn to use it since I paid the money. But it's really cheap compared to an iPad. So next problem, I can't help a whole lot. Oh, wait. What is that one? That one's already in rectangular. Oh, alternative form using, so he's saying go to trig to rectangular or go to rectangular to trig. So this one, I don't know if I can do that probably without a calculator. We can do that one. Let me just mark this off as that was that problem. I like my iPad with unlimited space. I could zoom in. All right, R must be square root of, there's my X squared, that's 25, plus, and there's a -4. -4 squared is 16. So R will be the square root 20, 30, 41. Well, bummer. He wants decimal answers. And I don't have decimal right now because I don't have a calculator. And theta. So, I mean, I'm going to write my answer with the square root of 41. That's the exact answer. Theta, I'm not going to be able to do that one either because I need a calculator, but that will be, I keep writing theta. Tangent of theta will be my y over x. What's the y value? It's the part that's with the complex number. So what are you going to write? You're going to write a -4. What's the x value? It's +5. So whatever that gives me, and I personally would like you to give 4 decimal places, if you can, you know, because that gets you prepared for calculus. Because the AP world says 4 is sacred. So once you have those answers, how do we write it? We're going to write it in the sys form. I'll just write sys. Let's put black so you can see what I'm doing here. The answer will be R sys. So R is the square root of 41. Sys of, let's see, I don't know. It's going to be whatever the arc tangent, because remember, we're going to have to go arc tangent or inverse tangent of a -0.8. So sys, I need to know what this is because that goes here. That's the angle. Okay. So you key it in. You got the answers. I gave you the PowerPoint. You can see what the answers are. Anything else? Nope, next page. Oh, and this is cool, but I had a whole class that did studying these pictures, studying what does complex numbers and fractals have to do with each other. The picture is called fractals, and there's 2 kinds. There's a Julia set, and there's a Mandelbrot set. Mandelbrot. They're made up with sequences of complex numbers. These are complex numbers using the Z, because the Z, I told you how it actually is coming out at you with a 3rd axis. So I'm not even going to go into this. Look up fractal images. They're so cool. I can show you how there's some programs that'll do a fractal for you. What happens, what is so cool to this is if you zoom in, like right here, you zoom in and blow that up, you know what it looks like? It just keeps repeating itself. Each of these pieces, if you zoom in, is identical to what it came out of. Even if you don't see it, there's more continuing. It goes forever and ever. Each of these pieces just keep going on forever. Fractals never stop. Now, I'm not going to determine if they're in the fractal set. It's I don't think the college is even teaching us to have to study fractals, but it is. If you go and look for fractal images, I'll try to put something together for you to see. Yeah, I think I will. Over the weekend, I'll try to make a movie out of a fractal for you. And then it's just cool. Products of complex numbers. Okay, what are we doing on that one? A product theorem. So they're going to give us a product theorem. Thank goodness they're going to give it to us, because most of us don't have them memorized. All right, so we know that r times cosine theta plus I sine of theta can be, why does he have another one here? It's got, I really need to zoom in on that and I can't see it. Yeah, I can put it on my other. I don't want to zoom in and it be, I don't want you to have to be worrying about the zooming in. I can zoom in on my other computer, not other computer, but my monitor. If I was just in PDF, you could zoom in on a PDF. All right. My eyes are that bad. R, okay, it's giving us two different, that's why, okay. Why they look the same to me? They look the same to me because I could not see, I can see it now that I see it on the other page. There's R1 and R2. Those are different radii, different hypotenuses. And the angles are not the same either. This is theta 1, this is theta 2, and theta 2. So we're dealing with R1, theta 1. We're dealing with R2 and a different angle, theta 2. So there are two different complex numbers. The problem could look like this. 2, well, do I want to put it in cis form? I don't think the formula is in cis form. Well, yeah, it's just down right down here it is. But anyway, 2 cosine, make it really easy, 30 degrees, and then plus the I sine of 30 degrees. You're going to multiply that by, change the color. We'll make it a 5 as the R, cosine of 60 degrees, and plus, why does it go back to that color? It's weird. Plus sine, oh, I didn't see, I need to be I sine of 60 degrees. So you're multiplying two trigonometric form complex numbers. He just says your product of complex numbers. You could have done this problem like this. You could have said, you could have two, I don't know what the answer is to this in, I don't know what that number is without doing the work, but you've done like 2 plus 3i times 1 minus 5i, and you would FOIL it and all that stuff. Well, that's what you're doing here, but they're written in trigonometric form. That's the problem. See, we're doing it in trigonometric form. It'd be so much easier to do it in rectangular. Okay, but if you don't want to do it rectangular. So when you're multiplying 2, I'm just going to jump right here so you can see what's happening. All you're doing is, just like you think you would do, you would multiply the two R's. And that makes some sense. See, R1 times R2. And then inside my parentheses, I'm taking the two angles and I'm adding them together and doing cosine of the sum plus sine of the sum. So you're just expanding it to the both angles. You're merging both angles. But it's kind of weird because I understand r times r, but why am I adding angles? But that's what you're doing. The cis shortcut is you still multiply the two r's and then go ahead and just do cis of the sum. So I could rewrite this problem as 2 times 3. I want to put 2 times 3 cis of 90, because that's what the sum of 60 and 30 is. Now, to do the work, you will have to expand those out and say, well, what is the cosine of 90? What is the sine of 90? Okay, now you just got to practice it a couple times. And does it give us anything else up there? Let's see, that is, we multiply the complex numbers. Well, I just said that. We multiply their, why do they have two spaces? There are, there's a name for that, probably, I don't know. We're multiplying their r's and we add their angles. I don't know why there's two spaces. Multiply their R1 and R2. I'll just do that. R1 and R2. I'm not sure what he wants. Okay, we have a practice problem. Okay, so we're going to multiply. Don't tell me it's the same one I just did. Oh, wow, it's so close to the one I did. All right, and they're good angles. We'll finish ours then. We may as well, since we'll do it after this one. So we know that the product, I'm going to do this. 3 cis, I'm lazy. 3 cis of 45 degrees times 2 cis of 4, oh no, that was how much? Whoop, wrong page. Did it back up? Oh, it's fine. Cis of 45 times 2 cis of 135. Oh, I like that better than 125 because that's just a multiple of 45. So I'm happy. I just rewrote this problem in cis because it was easier to write. And so even to keep it easier, oh, why did it do that for me? So the answer should be 3 times 2 is 6, just like my other problem was. Cis, add up, 45, 65, 75, 85, 90. Hey, I came up to the same thing as I just had. Okay, I don't have to do the other one again. It's come out to the same answer. Isn't that awesome? Oh, wait, no, it's not. It's not 35. It's 45 plus 135. 45, 145, 50, 180. Oh, well, I got excited for nothing. Yeah, 45, 55, 180. So I do need to know what the cosine of 180 degrees is. And I do need to know what the sine of 180 degrees is. But I don't need a calculator for those because 180 is located here. And the ordered pair is -1, 0. So we know that the cosine is a -1 and the sine is 0. So if I write it out, equals to 6 times the cosine of 180 plus I sine of 180. Then there's my cosine that I know is a -1. There's my sine right here. That's a 0. So the answer is 6 times the -1 plus 0. That would be a -6. That's just not very exciting. I didn't write the problem, so don't shoot the messenger. That's what that would be. In other words, if you write out the whole ordered, if you had to write it out, the real part's a -6, but it doesn't have it's a 0i. And if you were to graph that answer, it will look like the real part goes to right here to a -6, and it doesn't have an imaginary part. That's graphing the solution. Wow, that was fun. And quotient. Okay, now we're going to divide. Can I be honest with you? I don't know anybody who's ever had to divide complex numbers in trimmed form. Okay, the formula. So again, you got two different complex numbers here. Let me change the color to something more gentler. Two different complex numbers, each with their own angle. They could be the same angle, but for the most part, consider them as different. The formula is relatively simple. Look what we did. Instead of multiplying the r's, I divided. Instead of adding the angles, I subtracted. So there's my shortcut formula. Okay. That was really hard to think of, right? And I don't know what, I'm not going to try to fill in his blanks. Let's just do a problem. Okay, we're doing, so if